Hi, welcome to Math as a Language. Today we continue our discussion of functions, a bit more formal discussion. Functions we've described in a number of ways, and that's the nice thing about functions. There are many ways of representing functions. We've talked about mapping diagrams where we had a group of elements, maybe just 3, 2, and 1. And we had those input elements mapped onto or into output elements, and we'll go with a 5, 6, and 9. All right. So one of the thing about a mapping representation of a function is we have these pairings. You have 3 paired with 5, 2 paired with 6, and 1 is paired with 9. And we have these referred to as the input values. Those are the input values, but they had a number of names. We called them input values. We more formally called them the domain values, domain elements. And now we're going to also introduce them, and we might have alluded to this before, but we'll actually refer to them as the X values. That is to say, now these values, you'll notice the input values are independent. You can choose any values you want to be the input values. So these values are arbitrarily chosen, up to you. For that reason, they're referred to as the independent variables. They're independent. Independent. Independent variables. Okay, so they're independent. The X values are independent. And again, the output values, let's go ahead and do the various pairings here. That we can refer to these as the output elements. So those are the values that come out of the function, whatever that happens to be. Or domain generates the range values. So we have the range. X, of course, is paired with Y. And the Y values, if the X values are independent and you choose these arbitrarily, the Y values, the range values, are dependent. Okay. Now, what do we mean by dependent? For the most part, what we are suggesting is that now, in this particular case, let's get to it. We just chose these values, and now as far as whether this is a function or not a function, as far as we can tell, the main thing that we want to recognize is that we don't know what the rule is. Okay, there's no way you can tell just by looking at it what the rule is that's connecting this 3 with the 5, or the 2 with the 6, or the 1 with the 9. Now, if you can, that's fine, but if you cannot, the only statement you can make about this pairing, and you can decide whether or not it's a function. But in order to do that, what we will look at is simply put are these input values, are the input values paired with a single output value. So the 3 is giving you a 5, the 2 is giving you a 6, and the 1 is being a 9. There's no repetition here. And the most important thing is that you don't have a case where the one input values is generating 2 output values. And so in terms of expectations, for the most part, based on what we see here, we know what to expect. We know what to expect. And for that reason, we would say, yes, it's a function. Okay, so we know what to expect. Okay, but as far as the actual rule and the pairing as to why this is being generated, we really don't know. Okay, so now let's get beyond that. In a more formal presentation, let's take a look at another set of dependent and independent variables. Let's go ahead and, I don't know why I bracket these things, but for the sake of consistency, let's go ahead and do that. So let's say that we generate a new set of values, and this time we're going to refer to these guys in a more mathematical term. So we have our X values here. So we have our X values. These are your independent variables, and what we will mean by this in this particular case is that we will choose we'll choose about 3 values for our X values, and we'll do that shortly. But in keeping with our presentation here, we're going to have these X values generate Y values. Okay, output values. But here's the thing, when we generate it, we will go ahead now and actually state what the rule is. So in this case, now these are your dependent variables. Now, in mathematics, we can, this rule, the rule that connects the x to the y values, we can say it in words. Okay, so let's say that the x values, in order for you to get a y value, you take any input value and you would double it. Okay, but so if there's a doubling process going on here, what we would more often than not in math, the thing about mathematics in terms of efficiency, the more efficient way of saying that would be to say that the y values, the values that are being generated, are going to be, in this case, if we talk about doubling, is going to be twice any x value, any input value. Okay, and therefore this would be our rule. This would be the rule that connects the x values to the y. Now, as far as being independent, the independent variable, there's no, you can choose any value you wish as far as the x value. Any number from the real number line can be generated here, and we're going to only do about 3 of them here. Let's go with a -1. Let's go with a 4, and we can even go with a 0.6. Okay, so the point to be had here is that why we chose those values is anyone's guess. Okay, but these are the 3 numbers from the number line that we chose in order to generate this function. But notice now that we don't have that same luxury of just picking anything as far as the pairing goes. That has to be done according to this rule, and that's where the rule comes into play. All right, as I said before, as we said before in the first, we didn't bother giving the rule why this pairing took place. We just went ahead and did it. In this particular case, however, we have the pairing, we have the rule, and we have to adhere to this rule. And therefore, simply put, what we'll do is for any x value for this -1, we're going to go ahead and generate the y value dependent on this rule. So we have a -1 here. We have to double it, and therefore this value would become a -2. Similarly, we have a 4 here. We have to double it. So the 2 times 4 would be 8. And finally, we have a -6. We have a 0.6 here. 2 times 0.6 would be a 1.2. Okay. So notice now that the pairings follow the rule. Every x value, every domain element is being paired with a y value, and it's a unique y value. There's no, the -1 would, according to this rule, will never give us 2 different values, and therefore, yes, this is a function. Okay, but more powerfully, we have the rule, and we know exactly what the values are. So here's the thing: these values that were generated here were dependent upon which x values we chose. Okay, and so let's go ahead and now do one other thing. New concept here is when we have these values, these pairings. Obviously, we would like to have a nice, neat, concise way of representing this, and we're going to introduce the concept of an ordered pair. The x values, whatever the x values and the y values are now paired in this particular fashion. And this is, of course, this is referred to as an ordered pair. So we will represent our solution set as ordered pairs. Ordered pairs. Okay, and so let's go back up here and see. We'll go ahead and generate the value. We had -1 gave us -2. So we had -1. And when we double that, that gave us a -2. So that's our first ordered pair. Next we had, let's take a look. Let's go up a little bit. We had 4. Okay, so we had 4 was our dependent variable, and we applied the rule, and that gave us that was paired with a -8, our second ordered pair. And finally, we had a 0.6, so we can see that, and that 0.6 generated a 1.2. Okay, and so there we have it. These now become the solution set to the function that was defined, or that was described according to this rule, to the rule y is equal to 2x. Okay, all right, so there we have it. Okay, so we have a bit more formal look at the concept of a function. Again, we went back to our pairing. If we don't know the rules, so be it. What we ask is, do we know what to expect? In this particular case, we did. So again, the input values have a number of names. You can call it the input, the domain, x and y. Realize that the input values are independent. You get to choose those guys on your own. But however, the output values are generated according to the rule, whatever that rule happens to be for the function. Okay. All right. We're going to stop here at this point in time, and continue on looking at more, perhaps, functions and rules and pairings in future videos. All right. All right. Thanks for visiting. Take care, and we'll see you in the next video.